you think about how climate change affects the Arctic, the first things that come to mind are melting sea ice, raging wildfires, and thawing permafrost. But something interesting is happening to the plankton of Arctic freshwater lakes, and it could have some serious consequences. Let's talk about diatoms. Diatoms are phytoplankton, which means they are algae that can photosynthesize. They live all over the world in freshwater or saltwater, but today we're going to focus on freshwater diatoms. Diatoms have hard shells made of silica, which means they are fairly heavy and sink easily, which is important because they can't move on their own. They rely on the turbulence of the water around them to stay close enough to the surface where they can photosynthesize. For diatoms in Arctic and subarctic lakes, ice cover is hugely important. Let me take you through a year in the life of one of those lakes. Beginning in autumn, cold temperatures chill the surface layer of a lake. As water grows denser, it sinks to the bottom. The warmer water that rises is then exposed to the air and cooled as well. Eventually, once the entire lake is cooled, a layer of ice may form on top. At this point, the temperature of the lake is roughly the same throughout. In spring, the ice melts and warming air temperatures heat up the newly exposed surface water. This warm water starts to mix with cold, deeper water, creating turbulence. Diatoms love this because the turbulence created by mixing creates ideal conditions for them to remain near the surface. The sun continues to heat the upper layer of the lake throughout the summer. As it warms, it becomes less and less dense, floating on top of cooler, denser water below. Eventually, distinct thermal layers form in the lake. During this period of summer stratification, there is little mixing between the lake layers. So, what does this mean for diatoms? Well, the Arctic has some of the largest freshwater diatoms in the world. These lakes with winter ice cover and big seasonal changes have a lot of turbulence, which keeps these little guys afloat. But the climate is changing. As air temperature rises, the amount of time the lake spends under ice cover decreases, and the amount of time it spends in a stratified state with no turbulence increases. This spells disaster for those large diatom species, which are being replaced by smaller species that don't need as much turbulence. Diatoms are also known to have high nutrient requirements. When a lake spends a longer portion of the year in the stratified state, there's reduced delivery of new nutrients from deeper layers. This favors those little diatoms who have lower nutrient needs to survive. What's great about diatoms is that their shells are easily preserved in lake sediments. We can dig up those lake sediments and track how a lake's diatoms have changed over the past few hundred years. Since the Industrial Revolution, there has been an observed decline in Arctic freshwater diatom size. This has huge implications for climate change because these little guys work hard to counteract the carbon dioxide that we humans pump into the air. When diatoms photosynthesize, they remove carbon dioxide from the atmosphere and convert it into carbon. When they die, they sink to the bottom of whatever water body they are in and bring the carbon with them, where it's stored. The larger the diatom, the more carbon it can store. Arctic diatoms are getting smaller and smaller, which could help worsen climate change. It's important to remember that our actions as a species affect the entire world, not just the parts that we can see.